Hi, Niko Gentile here from Lund University, where I work with a group of 10 lighting enthusiasts. I would like to thank you for participating here today, and I would like to thank you also Miriam Arias and Ute Bessenecker, together with the Swedish Energy Agency, for organizing this lighting week despite the circumstances this year. Today I'm going to speak a bit about daylighting and integrative lighting. And the first reflection that I would like to do with you is, okay, we have a number of light sources out there, from LED to fluorescent to daylight and so on. But does an ideal light source for us exist? And the answer in this case is easy and straightforward. It does exist, and it's daylight. Yeah, I wish to apologize for this picture that you maybe have seen already hundreds of times, but it's just so good to describe daylight and the features of daylight that I had to use it. Daylight is an ideal light source for us because it's free, it's very energy efficient, of course, but also because we evolved under daylight, and we know today, we have scientific evidence that daylight is good for our mood, for our performance, on top of enabling vision, of course, but it's also necessary to regulate our sleep and wake cycles. Daylight, we like daylight for many things related to its dynamicity, and when it comes to sleep-wake cycles, I would say that today we should focus only on few aspects of daylight, and these two aspects that are important today is that daylight changes in intensity and color during the day, and this is particularly important for regulate our sleep-wake cycles. So we get colder intense light in the morning and dimmed and warmer light in the evening, and then eventually night. Why is that important? Because the light stimuli regulates the melatonin secretion. Melatonin is a hormone that we produce, and high concentration of melatonin make us feeling asleep. Blue enriched and intense light in the morning suppress melatonin, so we feel awake, we wake up and we are very alert. And then when we don't have light stimuli, or we have dimmed light stimuli and warmer light, we start to produce melatonin, and then eventually we fall asleep, and we need darkness there. So that's okay. The daylight works exactly this way, so it's perfect to regulate our sleep-wake cycles. But the big question is, we have a modern society, and we spend most of our daytime inside buildings where we have little access to daylight. So, can we actually measure the circadian potential of a light stimuli, so that we have actually numbers rather than just qualitative discussion here? And if we can do that, and since we are spending a lot of time indoor, can we actually regulate that potential and measure and regulate that potential with sources other than daylight? To answer the first question, yes, we can measure the circadian potential, and the way in which we can do, well, there are different metrics, and the one that we propose here today is the one that is the most known among practitioners, is called equivalent melanopic lux. It's very convenient because it's measured in lux, which is very similar to the unit that you're using in photopic or for photopic illuminance, which is the traditional illuminance that you have. The equivalent melanopic lux is used by the WELL standard, is a certification scheme, so it already did into a certification scheme. A very nice way to represent the melanopic stimuli is by making a ratio between the melanopic and photopic illuminance. It's called M/P ratio, and this indicates the alertness potential of light, where high M/P ratio over 0.9, it indicates a blue enriched light, which promotes, in a way, alertness. So we can measure that. The second question is, can we use other sources to promote circadian entrainment, to regulate the circadian potential? Yes, there are technologies, new technologies that goes under the name of integrative lighting. You probably heard them under the commercial names of human-centric lighting, biocentric lighting, human-centered solution, and so on. But basically they are the same system. Electric lighting system that during the day they dynamically changes in intensity and color of light. Are they popular? Yes, they are. Currently, I'm involved in an international project called IA Task 61. You get the website here, and thank you to Energimyndigheten, to the Swedish Energy Agency, because they are providing and they are helping with finding and helping with the participation in this project. In this project, among many other things, we are looking at different exemplary projects worldwide where they propose way to integrate daylighting and electric lighting in with different solutions. We have roughly 30 case studies worldwide, and about half of them they include integrative lighting. So yes, it's popular, and it's popular in Sweden as well. Here, one of the case study is called The Spark. Is an office building in Lund, quite recent, provided with abundant daylight, a lot of glazed surfaces here, and integrative lighting. We had LED lighting panels here, which are provided by a local company, quite good business, quite successful at the moment, and they installed the LED lighting panels in this The Spark building, and we monitored it. How does the system work? Well, we have cool and intense light in the morning is called boost scene, 6200 Kelvin, and horizontal luminance in the working space roughly 1500 lux, so very intense. And this changes going towards the afternoon. It dims down to roughly 450 lux on the workspace and the CCT of 2300 Kelvin, so pretty warm. The schedule is automatic and dynamic, so we go from boost to lounge during the day automatically, but the employee can override it manually through via some interfaces. So we did some monitoring there, both at the individual level, by giving to the employees some wrist-worn devices, light logger, that were measuring the color and intensity of light intake during the day at every minute. And they were also asked to they got a notification on the smartphone, and they had to report their self-reported alertness 3 times per day. We also did some simulation with Alpha, one of the few software existing today that allows for circadian lighting design. We did simulation because the pandemic kicked in while we were doing measurements, so we had to complement it somehow. And I'm saying we because, yeah, I was supervising the activity here, but the real monitoring was performed by 2 of the best master students I had in these years, Rawan and Jeren, who are acknowledged for having done an excellent work here. You will see some of their results. Here we have some simulation from Alpha with electric lighting only, so it's night time. Let's look at melanopic over photopic ratio. The melanopic over photopic ratio is pretty high with the boost electric lighting scene, the first one, cold and intense lighting. And if you remember, it should be higher than 0.9 to say that light is blue enriched, and so it promotes alertness, and so it does with the boost setting. And then it drops down to 0.5 when we go to the dimmed and warm scene. But that's good news, because the electric lighting is working as it is supposed to do. But then the good news, in my opinion, is that when we have daylight, this is a spring morning with clear sky. When we have daylight, it doesn't really matter the electric lighting scene that we are using. The M over P ratio is constantly around 1, independently from the electric lighting. So is daylight the big driver here for the melanopic stimuli? And that's a very good news. It means that we have a good access to daylight, and electric lighting can't do much in that case. We also had some results about the alertness of user. Here on the y-axis you should read CCT and illuminance, so growing CCT and growing illuminance, and on the x-axis you should see growing self-reported sleepiness. So we see that 5 employees that we investigated, that constantly have a sleepiness that is increasing when CCT and illuminance is decreasing. And here we just have 5 subjects. It's not very scientific, but at least it's in line with what science says, so we were quite happy about that. So to conclude, I have to complement my legitimate questions with some legitimate answers. For what we know, can we measure the circadian potential of light stimuli? Yes, we can, and I show you the melanopic lux or the melanopic over photopic ratio. They're a good example, but the scenario there with metrics is constantly evolving, and I'm not sure that in 6 months this M over P will still be the main metric. So it's changing, and it's changing fast. And can we regulate that potential with sources other than daylight? NIA, yes or no. We can do it in part when daylight does not suffice, but still we have to promote the use of daylight because that's the best regulator. So the take-home message is plan for good daylighting and then complement that with good, well-designed, well-implemented and energy-efficient integrative lighting. Thank you for your attention.